Everything around us is made of something. This something is matter. Matter is anything that takes up space and has weight. But what is matter made of? If we keep breaking down matter into smaller and smaller pieces, we eventually reach the smallest unit, the atom. Atoms are incredibly tiny, invisible to the naked eye. Imagine a grain of sand. It contains billions upon billions of atoms. Atoms are the building blocks of everything we see, touch, and even breathe. They are the fundamental units that make up elements, which are the simplest pure substances found in nature. From the air we breathe to the water we drink, everything can be traced back to these tiny particles. Atoms are constantly in motion, vibrating and moving around. They can combine with each other to form molecules, which are the building blocks of more complex structures, like cells, tissues, and organs. The study of atoms is crucial to understanding the universe and our place in it. By understanding atoms, we can unlock the secrets of matter and energy, leading to groundbreaking discoveries and technological advancements. Atoms, despite their minuscule size, have an internal structure. They are not just tiny, solid balls. At the center of an atom lies the nucleus, which is much smaller than the atom itself. The nucleus is home to two types of particles, protons and neutrons. Protons carry a positive electrical charge, while neutrons carry no charge, making them neutral. The number of protons in an atom's nucleus determines what element it is. For example, an atom with one proton is hydrogen, while an atom with 8 protons is oxygen. Orbiting around the nucleus are electrons, which are much smaller than protons and neutrons. Electrons carry a negative electrical charge, and they are constantly in motion around the nucleus. The arrangement of electrons in an atom determines its chemical properties, such as how it will react with other atoms. The atom structure is mostly empty space. If we imagine the nucleus of an atom as the size of a marble placed in the center of a football stadium, the electrons would be like tiny flies buzzing around the outermost stands. What makes one atom different from another? The answer lies in the number of protons in its nucleus, known as the atomic number. Each element has a unique atomic number. For instance, all carbon atoms have 6 protons, while all oxygen atoms have 8 protons. The number of protons also dictates the number of electrons in a neutral atom. Since protons have a positive charge and electrons have a negative charge, they balance each other out, making the atom electrically neutral. However, atoms can gain or lose electrons, becoming ions. Ions are atoms with an electrical charge. If an atom loses an electron, it becomes a positively charged ion, called a cation. If an atom gains an electron, it becomes a negatively charged ion, called an anion. The concept of atomic number is fundamental to understanding the periodic table, which organizes all known elements based on their atomic number and chemical properties. Elements in the same column of the periodic table share similar chemical behavior due to their similar electron configurations. Let's delve into some fascinating facts about atoms. Atoms are mostly empty space. As mentioned before, if an atom were the size of a football stadium, the nucleus would be like a marble in the center, and the electrons would be tiny flies buzzing around the edges. Atoms are constantly moving. Even in solid objects, atoms are constantly vibrating and moving within their structure. The amount of movement depends on the temperature. Hotter temperatures mean faster moving atoms. Atoms are incredibly old. Most of the atoms that make up our bodies and the world around us were created billions of years ago in the hearts of stars. We are all made of stardust. The elements heavier than hydrogen and helium, such as carbon, oxygen, and nitrogen, were created through nuclear fusion in stars. When stars die, they release these elements into space, which eventually become part of planets and living organisms. Atoms can bond to form molecules. Atoms can share or transfer electrons with each other, forming chemical bonds. These bonds create molecules, which are the building blocks of everything around us, from water to DNA.